All right. Good evening from my end here. So I have today we'll be talking about NumPy arrays. NumPy arrays. NumPy arrays and operations. All right. So today is for day 2. So let's edit this guy properly. Sorry. Oh, okay. I think we'll manage. Day 2. Yeah. Day 2, NumPy and operations. So, a brief of introduction about what we are going to do today. The NumPy, as the name implies, is derived from numerical Python. Numerical Python. So we have it here. Numerical Python. All right. So it is a powerful library that is used for numerical computing or computation in Python. So anything that has to do with numbers, numerical computation, numerical simulation, and so many of them, NumPy is one of the best tools to use, right? And then it provides support for large multi-dimensional arrays and matrices. Okay, so one of the beautiful thing about this guy, it's actually a data structure, but it's an advanced data structure because it supports very large form of data sets, right? And then not just supporting large data set, it as well supports several multi-dimensional arrays. So if we are looking at our Excel sheet, we'll only be trying to figure out 2 dimension, that's the row and the column, right? But this guy can actually accommodate multi-dimensional arrays. So to n dimension, like to any kind of dimension we want to give it. And not just arrays as well as matrices, right? So alongside with mathematical functions to operate on them. So it has its own inbuilt mathematical functions to that can be used to operate those variables, right? So how do we make use of this NumPy, right? So if you look at this very closely, there's something I wanted to say before I come to the how. Why do we need this, right? Why we need this is because one, when you're dealing with data science, you will be exposed to a very large data set, right? And then as well, there might be times you may want to perform one operation or the other, or you're trying to simulate, so you're trying to find relationship between one variable and another, or trying to create a new relationship that is dependent on two or more one or more, two or more parameters. So by so doing, NumPy is that particular tool that will help you achieve that with ease. So that is one unique thing about NumPy. So how do we then apply this NumPy? How do we use this NumPy as we have stated? The first step is to do what? You start by installing NumPy if it is not pre-installed yet, right? So if you want to install it, you use the command pip install NumPy. So there are 2 ways to doing this. You can easily install it from your notebook here by giving an exclamation sign pip install NumPy. Then if we run this guy, right? Let's run it and see. Mind you, during your installation, you need to be connected to internet. You need the internet service, right? So here is telling me what requirements already satisfied. That means I have NumPy already installed in my PC. But when you're installing any package on your notebook, it can only be used on this notebook. So I usually advise during it, when you want to install maybe a library that is not installed yet on your Python, come back to your directory and then make use of this your new guy and come to your terminal, right? So at this terminal is where you can install. So we type pip install, right? Okay, pip install NumPy. So that is what we do. Pip install NumPy. P, not YMU. All right, then you click on enter. So it will download it and install it automatically for you. But for mine, remember, it was already stated that requirements are already what satisfied, right? So let's forge ahead. Having installed it, you are good and ready to start using it. So, but now we have to understand how this NumPy works, right? So the first thing is that what makes up this NumPy is array. That's word array. So whenever you're making use of a NumPy, the arrays are actually what helps you to understand NumPy very well. So these arrays are just like will I say lists? No, not list. They are just the way um your datas or your parameter or your values are being arranged. So I think it comes from the word arrange, right? So you can arrange your data in different segments and in different ways and patterns, right? So we need to really understand how arrays work. So NumPy arrays are more efficient than Python lists. Remember, I told us that they are more efficient than what Python lists. So let's back up our statements because they provide the following. The first thing is what they are faster. They have faster computations. Um, uh, they have sorry, they execute computations faster, right? And also, they consume less memory consumption. And as well, they do what? They support for vectorized operations. So when we mean vectorized operations, so starting from matrices, and then vectors that has to do with three dimensions, ijk rather, that's xyz. And then, so NumPy array allows us to do what? Perform vectorized operations. So even when you want to perform plots that has to do with three dimensions, what will help you achieve those plots is what? NumPy. So let's start with creating NumPy arrays. The first is what? We'll create one-dimensional array, two-dimensional, and three-dimensional arrays using np.array. All right, let's go with the first dimension, one-dimensional array. So in one-dimensional array, before we can even make use of this NumPy, mind you, we've already installed it. But then, because we've installed it doesn't mean it will come up here automatically. We have to call it, right? So in calling it, we say import NumPy as np. Import NumPy as np, right? So we are trying to install NumPy as np. So if I run this code, we have it, it's run already. So you import the library. Mind you, we install first. That's when the package is not in your Python terminal. And then secondly, you now import it into the notebook you're working with. So how do we create a one-dimensional array? So you just have your variable name, array. Mind you, we imported this guy as what? NP. So whenever we call NP is the alias name, right? NP.array, we have array. Open a bracket, and then a list of what you want to use to create your array. So now, we now create what? Print one-dimensional array, and then you also print what? Array 1. So array 1 is a variable name for the one-dimensional array. So if you run this code, you have this guy here that is saying what? One-dimensional array, 1D array is equivalent to what? 1, 2, 3, 4, 5. So bracket open and close. All right, let's forge ahead. Creating a two-dimensional array. Let's look at how we can create a two-dimensional array. Mind you, in one-dimensional array, we had just, and there are critical things I want us to take note now. We had just one square bracket, closed and open and closed. And then when we come to two-dimensional array, we have already array 2 equals to np.array, right? So we now have the first square bracket opened, and that same first bracket has a close. So you open and close the first bracket. Then the second bracket is the one that will be bearing the first element, or rather the first row of your data, right? Then the second is the second row of your data. So we now print that what? Sorry, this guy was not supposed to be here. Let's come down. All right. So when we print this, you'll realize that we have sorry, I'm trying to create space for, oh bullshit. We didn't do this properly. Okay. So what I'm saying in essence is that this is our first row, and this is what? Our second row. So it has two lists inside of it, right? And let's still go ahead and try to create the one of 3 dimension. So I presume you should know what should come next, right? We should be expecting 3 square brackets. We should be expecting what? 3 square brackets. So I have the first one being opened and is closed here. And then I have the second one here, is open here and is closed here, right? Then the third one is open here and closed here, and then the same guy open here and closed here, right? So it means that from here to here is a 2-dimension, and then if I'm taking from here, it becomes the 3-dimension we're talking about. So we run this guy, and you realize, look at how it looks like. We have the first row, the second row, the third row, and the fourth row. But then look at what I'm explaining now. We have this guy alone is the first dimension, right? Then if you include this second one, is the second dimension. And then when you bring it down, it becomes the third dimension. So the next thing we're looking at is indexing, slicing, and reshaping, right? The first is indexing. What is indexing? Indexing is when we are trying to do what? To pick an element or to sort for an element in our array. So when we are trying to pick out an element from an array, we make use of what? Its index number. That's when we are dealing with NumPy. So it's similar to that of Python list and all of that. So where we make use of the index number. Remember I told us weeks back that we have this guy, right? So let's try to create something. All right, we have a list 10 to 50 in step 10, right? And then this is my first guy, which is 10. It has what? Okay, let's do this. Tens equal, let me bring our minds back. Tens equal what? 10, 20, 30, 40, 50, right? And then we are saying that we want to pick out this first guy. This is a list now, right? So if you say type of tens, it should give you a list, right? Let's see. Type of tens. So I know this should be a list, right? All right. So is a list, we confirm. So we want to pick the first value there. Remember, the first value will be tens. No, this should be tens. Why am I misspelling today? Okay. Tens, then this guy and 0. So if I click on run, I should be having 10 as the output. So it tells us that the first value is represented by what? 10. So, but index number is what? 0. So if I say 1, then the next thing that should come out is 20. Then if I should change this guy to 2, the next thing that should come out is what? 30. So it automatically tells you that when you start counting based on index, you should start from what? 0, right? And then that's when you're counting from left to right, you start from 0. Then when you're counting from right to left, it starts from -1. And then see, it's just like your Cartesian plane, that when you're moving from the left to the right, the number increases. While you're moving from the from the right to the left, the number reduces. So it's as simple as that. So now we want to pick out the second value here. So we want to pick out the second value. So we will say that once pick out the second element in this our array. Mind you, we've created an array here. np.array, open the bracket, and then this is one dimensional for sure. You should know that. So print element at index 2. Mind you, we are picking element that is in index 2, not the second value in our array, please. The element at index 2. So if we run this guy, the element at index 2 is 30. Reason being that this guy is 0, 1, sorry, 0, 1, and what? 2, right? So that confirms that for us. So it is as simple as that. And then we can go ahead. We can, sorry, okay. All right, let's continue. All right, so the next thing is, let's pick out the first, okay, we're dealing with one dimension here. This is how to pick out numbers for a one-dimensional array. So what you do is, I think I have to make this code more simple. Okay, let me see what I can do. I want to explain that I didn't capture on time. So, all right, so this is it. Array, then open 2, index number 2 with 30, right? So now we have an array like this. Okay. So we have an array like this, right? And then I'm running this guy. Okay. So I want to pick out the element in row 1 and column 2. This is it now. Element in row 1 and column 2. Element at row 1 and column 2. Okay, so let's go. The first thing is, if we run this guy, let's try to run this guy and see what comes out. So element in row 1 and column 2. Element in row 1 and column 2. So this is our row 1, and this is our column 1, and this is our column 2, right? So how do we pick that? How do we pick that? How we pick this element here that is in row 1 and column 2 is that, let's go up, we'll have array 2, right? That's the variable name. Array 2, right? And then remember, our first row, the index value for your first row is usually what? 0, 0, comma. We want to look at the index of the column. The first column is what? 0. The second column will become what? 1. So here will be 1. And when we run this, we should have 2 being displayed here. So this should have been element in row 2. Sorry, that's what I wanted to confirm. Yeah, elements in row 2 and column 3, right? So if we are doing this one, our output should be what? 6. The element at row 2 and column 3 is what? 6. But assuming I said element in index, element at row 1 with index number 2 and element in column 3 with index number 2. It will now give us what? This, because we have here what? 1, 2. So it will come here and look out for 1. This is 0. So it will come to this one, which is 1, and do what? Pick the one that is 2. So inside 1, we have 0, 1, 2. So it picks 1, 2. So this is 1. The entirety of this stuff here is 1. And then this other guy inside becomes 2. All right. So we've run this code already, I think so. All right. So let's progress. Slicing NumPy array. So the same pattern that we used, or the same method that we applied before, is what can be applied here as well. So we are having slicing NumPy array. Slicing allows selecting sub arrays, right? And then here is it. How do we do this now? We have an array from 10 to 50, that array we created before. So now we want to slice from index 1 to 3. So whenever you hear index 1 to 3, it's actually the index. So one beautiful thing here is that one beautiful thing here is that, okay, let me have this to be index 1 to 4 so that I can explain what I want to explain. All right, so if you run this, you'll be having 20, 30, 40. All right, so we have here 0, 1, 2, 2, 3. Okay, it's 3, please. Sorry. Pardon, it's 3. All right, we have 0, 1, 2, 3, right? But then when you're slicing, the first value represents your start point. And then column, whenever you put a column, it means that you're expecting a value, an index number that will end your slicing. But that value or that element in this index number that is ending your slicing will not be included in your output. So if, for instance, as we have here, column 4, someone would have said, since this is 1, and this is 2, and this is 3, and this is 4, right? So it means it should have been 20, 30, 40, 50, but that's absolutely wrong, because what Python will do is that it will pick from the beginning of your slicing, which is index number 1, down to the last index number minus 1, right? So minus 1 being 3, yeah. So that's why it's displaying what? 20, 30, and 40. This is for one-dimensional array. So let's look at two-dimensional array. Under two-dimensional array, mind you, we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to pick out the arrays. Want to slide row 0 and 1, column 1 and 2. So row 0 and 1, column 1 and 2. So the first set of index numbers you'll be putting here in this your slice, represent your rows, your rows, your rows. And then the one here represents what? Your columns, right? So because we are choosing index 0 and 1, so that means we will start from, when it's starting from 0, you can leave it, not just put anything. And then when you're ending with 2, or when you know that the last value is what will end your slicing, you might decide not to put it, right? So like for instance now, we have first row, which is index number 0, second row, right? And then third row. And then we have first column, second column, and third column. So this first column is index number 0, index number 1, and index number 2. So we need column 1 and 2. So it will now start from this guy with index number 1, and ends with this guy with index number 2. So, but if you come here to say you want to put this guy 2 and you want to put here 0. So let's see what will be the output. You realize you end up printing just 2 and 5. Meanwhile, we needed what? The index values from 0, from 1, from 0 to 1, and as well from what? From 1 to, it was from 0 to 2, but that 2 will not be inclusive, right? And then from what? 2, from 1 to 2. So this is how it should look like. So if we are running this guy this other way, so let's put this guy like this and bring out this 0. So I will have this to run. Realize we are having what? 2, 3, 5, 6. All right, let me explain. So if I should print out, so let's print out array 2, so we can use it to explain better. Array 2, right? Array 2. All right. So this is our first row with index number what? 0, right? Then this is our second row with index number what? 1. So it means that we've secured the fact that we are dealing with index rows that has index number 0 and 1, which is this first guy and this guy, right? And then, but with the columns, we want to look at column with index number 1 and index number 2. So this is a column where the index number will start from 2. Remind you, this one that is 147 is column with index number what? 0. Then this 258 is column with index number what? 1. And then this 369 is a column with index number what? 2. So that is why I'm choosing from 0 to 2, right? From that 0 to 2, it means that I'm taking everything in this first row and this second row. Mind you, the last number in that index will not show, will not show. So that's why we neglected this last row. But then there's another restriction here that says, okay, I know you're choosing everything from this first row and everything in the second row, but please limit it to column number 1 to 2, right? So I will now choose column number 1 and 2. Column number 1 and 2. That's why I have what? 3, 2, 3, 5, 6. So that should have explained that. Spend a whole lot of time there. So, but it's worth it, right? So, because when you use all of this and you understand how it works, you appreciate it more. So let's look at the second, I think it should be the second to the last thing we'll be doing today. It's called reshaping arrays. Reshaping arrays. We want to learn how to reshape arrays. All right. So, first of all, let's look at how to take array shape. So if you have array2 dot shape, right? And let's run this guy. You realize that it's a 3 by 3 matrix. It's a 3 by 3 matrix. 3 by 3 does not mean that it's a 3D, right? So if it is a 3D, it should have been what? 3 by 3 by something else. So this is a 2D. So if you want to check the dimension, all right. So let's check the dimension. I think I was supposed to include all of this. So, but let's check the dimension. Dot and dimension. Hope it works for us. Yeah. So this is 2 dimension, right? So if you check the one of that one, let's still check one array 1 dot n dimension should be what? 1. And that of 3 rather, array 3 dot n dimension. I'm saying 3 and I'm typing 2, sorry. 3. That should give us what? This is 3 dimensions. So let's check the shape of array1 dot shape, right? Array1 dot shape should give us what? 5 comma nothing, because it's just one array, right? And then, sorry, just one dimension. Then that of 3, array 3 dot shape should now be what? 2 by 2 by 2. So I hope this explains what I was trying to say. So, but then we want to learn how to reshape from probably 3 by 3. Okay. When you're reshaping, you need to have a little knowledge of, I think, how your squares work, right? So you cannot have a 2 by 2 kind of shape being turned to a 3 by 2. No. So, but you can have uh, a 2 by 3 turned to a 3 by 2, right? So it's either ways. So let's try to reshape and see what will come out of this. So we have here array, this guy. So this array, right? There's something I want to do. I hope it comes out well. All right. So I have this guy, array. So let's check the shape of this array before we start reshaping first. So this guy should be a 6 by nothing array, right? So this 6 by nothing array we can have it to be reshaped to 3 by 2 or 2 by 3. The reason is that we can have a whole number of elements that will fit into those 3 and 2, 3 rows and 2 columns, because 3 times 2 will give us 6, and then 2 times 3 the other way around will still give us what? 6. So reshaping to 2 by 3 matrix will have what? Array dot reshape. That's the word, reshape. Then you now put the shape you want it to become. So when we run this, it becomes like this. So the same thing applies for any kind of shape you want to create. Just understand how it works. So let's try to do some basic operations. Remember, today was supposed to be right NumPy array and operations. So the first is I have an array 1 to 3, and then I have another array 4 to 6, right? So I want to add the two arrays together. Let's see how it comes out. We'll be having what? 5, 7, and 8. So what this does is that it adds 1 plus 2, 5. Sorry, 1 plus 4, 5. 2 plus 5, 7. 3 plus 6 becomes what? 8. It adds with respect to what? Their index number. So the index number 0 for array A will be added to index number 0 for array B, because your command here was what? A plus B. So it adds that way. The same thing is applicable for subtract. If you want to subtract to become this way, this. And then it also goes through for a dot multiplication. A dot multiplication. Why do I say a dot multiplication? Is because when you have a product, a cross product, is more complex than this. We're not doing matrices here. So that is basically what this dot product will do. Dot product will just do 1 times 4 gives us what? 4. 2 times 5 gives us what? 10. And 3 times 6 will give us 18. So the same thing is applicable for division, right? And all of that. So lastly, broadcasting. NumPy automatically adjusts smaller arrays in operations. So if you have this guy and you want to run this, so we have 1, 2, 3, 4, 5, 6, and then we want to multiply by a scalar, which is 2. So you're multiplying 2 by 1, give you 2, 2 by 2, 4, 2 by 3, 6, and all of that. So today I decided to make today a free day. No assignments, no classwork, no exercise, just enjoy the whole ride. Thank you so much for listening, and see you in our next video.